This is a recent video from Dave Weiss where he talks about resolution, perspective, and how the horizon is formed on the flat Earth. So let's have a listen.
Globe believers want you to believe this is Earth curvature. The truth is, this is just the limit of our vision.
I don't agree with this one because if the horizon is the limit of our vision, then why do we see things beyond the horizon?
Our eyes have a limit on how small of an angle they can see.
This is true. Here's an eye chart, and if you're able to read the line for 20/20 vision, that means that you can resolve 1 arc minute or about 0.017 degrees. For 20/20 vision, each segment of the letter is 1 arc minute in size, and the entire letter is 5 arc minutes in size. So, which is the smallest line that you can clearly read? And I think everybody knows that the unresolvable letters are just too blurry to read. Although flat earthers seem to believe that when things become unresolvable, they start getting cut off at the bottom.
This man, when looking down at the beach, has a large angle of view and can resolve all the details of the ground near his feet. When looking out a little ways over the water, his angle of view is still pretty good. Even though some of the information is being compressed due to perspective, he can still resolve much detail of the water's surface. When he looks all the way out as far as he can see, his angle of view is almost level with his eyes, and he cannot receive any detailed information due to perspective compression.
This is easily demonstrated with this graphic because you can clearly see how much smaller the angle is to that far segment.
This becomes his horizontal eye zone, or horizon for short. When viewing a flat surface with almost no measurable angle of attack, that flat surface will reflect the sky above and create that horizontal line we call the horizon.
Now, I don't agree with Dave that a flat Earth horizon would form because of skylight reflecting off a flat water surface. The horizon is just the boundary where we see light from the sky and light reflected from the water. So to understand how a flat Earth horizon would actually form is just a matter of understanding how perspective works. Now, as shown in Dave's video, the farther you look out on a surface, the less details you can see of that surface. And on this drawing, we can clearly see that the horizontal lines on the surface appear to get closer together as they get closer to the horizon line. Now, since the surface does appear to compress as it nears the horizon line, on a flat Earth, the water beyond the horizon would be merged into the horizon line. Now, we see the same effect on a globe, except that water beyond a globe horizon starts to curve down. So to better understand how this works, let's answer this question. How far is 1 mile for a 6-foot person standing at the edge of the seashore? Now, this is just a simple matter of finding the size of this angle, which is a triangle that is 1 mile long and 6 feet in height. And that is easily calculated using this trigonometric formula. And this gives us an angle of 0.065 degrees, which is a very small angle. Now, this drawing is not to scale. On a scale drawing, the angle would look more like this. Now, remember that letter E from the eye chart for 20/20 vision? Well, that 0.065 degrees is a little bit smaller than the angular size of the letters for 20/20 vision when you take an eye test. This also means that the surface beyond 1 mile is within this 0.065 degree angle. Now, the same is true for the globe because at 1 mile we only have 8 inches of curvature drop. So again, if the Earth was flat, all of the miles beyond that 1 mile would be within that very small 0.065 degree angle. Now, when I do a calculation for 4 miles, I get 0.016 degrees. And this is really the same angular size as each letter segment for the letters that are used for 20/20 vision on an eye chart. And since the surface beyond 4 miles would be within this 0.016 degree angle, that means that the surface beyond 4 miles would not be resolvable. So for a person with a 6-foot eye level who is standing at the sea's edge, a flat Earth horizon would form at about 4 miles. And all of the water beyond the flat Earth horizon would be merged into the horizon line. Now, I think it's also pretty easy to understand that this is a horizon that could not obstruct the bottom of objects beyond the horizon. Now, for the same person on a globe, that horizon forms at about 3 miles, and the water beyond a globe horizon curves down. Now, this is a horizon that can obstruct the bottom of objects beyond the horizon.
We were all taught in our government-run indoctrination camps, also known as schools, it is Earth curvature that causes this line. But thanks to today's consumer optics, we can zoom in and use some critical thought. Are they dolphins behind the physical curve of the Earth and jumping above a physical obstructing horizon so we can see them? Or are they just beyond the angular limits of our eyes, ability to discern information from the surface of the ocean?
Well, yes, most likely those dolphins would be smaller than the resolution limit of the human eye, but just because you can zoom in with a P900 and see them is not proof of a flat Earth. Here's a screenshot from this video, and he also used a P900. So why is the hull of this ship hidden by the horizon?
We can zoom in and use some critical thought.
So yes, let's use some critical thought. Since the water beyond the flat Earth horizon would be merged into the horizon line, why wouldn't we see this ship floating on top of that water? Or do flat earthers think this ship is sinking? And let's have another dose of critical thought. Because we live on a globe and water beyond the globe horizon curves down, it makes perfect sense that the hull of this ship would not be visible. Of course, Dave has another flimsy excuse for bottom-up obstruction. Here he asks the question, how can a 3-foot wave block a tall ship from a 6-foot man on a flat Earth? Well, Dave, can you tell me which one of these tiny waves is hiding the hull of that ship? Well, I think it's pretty obvious that Dave's claims do not hold water.